This will now be our equation 2. Dividing equation 1 by 2, we have 4.2 divided by 3.7 equals to 2 pi divided by 2 pi in bracket square root of length over gravity all over square root of in bracket length minus 1 all over g, which will now give 4.2 over 3.7 equals to square root of L over G all over square root of in bracket L minus 1 all over G close bracket. This will now turn out that the G will cancel out. We have square root of L over G times square root of in bracket G over L minus 1 if L jumps up. We now have square root 4.2 over 3.7 equal to square root of L over square root of L minus 1. Removing the square root to the other side, we have square root of 4.2 squared over 3.7 squared equals to L over L minus 1, which we now have square root of 4.2 as 17.64 over square root of 3.7 will be 13.69, which will now give us L over in bracket L minus 1. Cross multiplying, we have that L 13.69 L equal to 17.64 L minus 1. 13.69 L is equals to 17.64 L minus 17.64. And taking the like times together and the known figure on the other side, we have 17.64 equal to 17.64 L minus 13.69 L. 17.64 will now be equal to 3.95 L. L is equals to 17.64 over 3.95, which will give us 4.46 meters. The original length is therefore 4.46 meters. Example 7. A particle of mass 10 raised to power minus 2 kg is fixed to the tip of the fan blade, which rotates with angular velocity of 10 radians per second. If the radius of the blade is 0.2 meter, what is the centripetal force? Solution. Mass is given as 10 raised to power minus 2 kg. Angular velocity equal to 10 radians per second. The radius of the blade of the fan is 0.2 meters. Velocity is equal to omega r, which is now equal to 100 times 0.2, which will give us 20 meters per second. F is equal to mv squared over r. As we now replace the unknown values, which we now have 10, which is the mass, minus 2, 10 raised to power minus 2 times v squared, which is unknown, all over 0.2. Therefore, 10 raised to power minus 2 times 20 squared, which over 0.2. Our force F is now equal to 20 newtons. Density and relative density. Density ρ of an object is the mass of the object m per unit volume v, or ρ equal to mass of m over v volume. The unit is kilogram per meter cube, that is kg per meter per cubic meter. Relative density, RD. Relative density of a substance is the ratio F, the mass of any volume of it to the mass of equal volume of water. Relative density RD is equal to mass of substance over mass of equal volume of water. Relative density has no unit since it is a ratio of similar quantities. In this case, two masses. Archimedes' principle. Archimedes' principle states that when an object is wholly or partially immersed in a fluid, it experiences a loss in weight or an upthrust which is equal to the weight of the fluid displaced. Apply it to relative density, RD will now be. Apply it to relative density, RD, we have that relative density equals to weight in air over apparent loss in weight in water, or relative density equal to weight in air over upthrust in water. Law of flotation. This states that when an object floats in a fluid, upthrust exerted upon it by the fluid equal the weight of the object, or it states that a floating object displaces its own weight of the fluid on which it floats. Example 1. A solid weighs 4.8 grams in air, 2.8 grams in water, and 3.2 grams in kerosene. Calculate the ratio of density of the solid to that of the kerosene. Solution. Mass of solid in air equals to 4.8 grams. Mass of solid in water equal to 2.8 grams. Mass of solid in kerosene equal to 3.2 grams. Relative density equal to weight of solid in air over apparent loss of weight in water. Relative density is equal to 4.8 over 4.8 minus 2.8, which is now give us our relative density as 2.4. Relative density equals to weight of kerosene over weight of water in the same volume, which is equal to 4.8 minus 3.2 over 4.8 minus 2.8, which will give us 0.8. Density of solid over density of kerosene will now be equal to 2.4 over 0.8, which is equal to 3. The ratio of the density of solid to that of kerosene is 3:1. Example 2. 40 cubic meter of liquid P is mixed with 60 cubic meter of another liquid Q. If the density of P and Q are 1.00 kg per cubic meter and 1.6 kg per cubic meter respectively, what is the density of the mixture? Solution. Mass of liquid P equals to volume times density, which is equal to 40 times 1, which will give us 40 kg. Mass of liquid Q equals to volume times density, which is equal to 60 times 1.6, which is 96 kg. Mass of the mixture is now equal to 40 plus 96, which will give us 136 kg. Volume of the mixture equals to 40 plus 60, which is 100 meter cube. Density of the mixture equals to mass over volume, which is 136 over 100, which will give us 1.36 kg per meter cube. Example 3. An empty relative density bottle has a mass of 20.0 grams. When it is filled with petrol, its mass is 55.0 grams.